Hello and welcome. Today we are exploring a fundamental question about one of the most important metals in our world. What is the melting point of copper? Let's get right to the answer. The melting point of pure copper is 1084.62 degrees Celsius. That's an incredibly high temperature. To put it in other units, it's 1984.32 degrees Fahrenheit. For scientists, that temperature is 1357.77 Kelvin. This number is not just a random fact, it's a key to understanding why copper is so useful. To give you some perspective, water boils at 100 degrees Celsius. This means copper needs to be over 10 times hotter than boiling water just to start melting. Your home oven might reach about 250 degrees Celsius, which is nowhere near hot enough. This high melting point makes copper durable for things like electrical wiring and plumbing pipes, as it won't melt under normal or even moderately high temperature conditions. So, what happens when copper reaches this temperature? At 1084.62 degrees Celsius, the solid, reddish-brown metal transforms. The atoms inside, which were vibrating in a fixed structure, gain enough energy to break free. They start to flow, turning the solid copper into a glowing, orange-yellow liquid. This ability to turn copper into a liquid is crucial for many industries. It allows us to cast copper into different shapes. We can pour it into molds to make everything from intricate statues to simple fittings. It is also essential for creating alloys. For instance, bronze is made by melting copper and tin together. Brass is created by melting copper with zinc. Knowing the precise melting point is also vital for processes like welding and brazing, where we join metal parts. Compared to other common metals, copper's melting point is quite interesting. It's higher than aluminum, which melts at about 660 degrees Celsius, but lower than iron, which requires a much hotter 1538 degrees Celsius to melt. This specific melting point is a defining characteristic of copper and can even be used to help determine its purity, as impurities often cause it to melt at a lower temperature. So, the next time you see a copper wire or a penny, you'll know the incredible heat required to shape it. Thank you so much for watching this video. If you enjoyed learning about the science of copper, please give this video a thumbs up and consider subscribing to support the channel. Your support means the world and helps us continue making more videos. We'll see you next time.